Here we have a problem on differential equations. Given is a causal linear time invariant system which is characterized by the differential equation and it is initially in rest condition, which means initial conditions can be considered to be 0. So the differential equation is given in this way, where you can see here d square y of t by dt square plus 7dy by dt plus 10y of t is equal to 4x of t plus 5 dx of t by dt, where x of t and y of t are the input and output respectively. And we are asked to find the impulse response of the system. So we need to understand what is a causal linear time invariant system here in this problem. So what is the find out here? It is the impulse response. And what should be understood to solve this problem is we need to understand what is a causal system. We need to apply Laplace transformations to obtain the transfer function y of s by x of s. We need to understand what is an impulse input. We need to apply partial fractions, and we also need to apply inverse Laplace transformations. Now coming to the solution part, having understood all these following topics, the first topic is causal system. Any system which is having a value equal to 0 for all time t less than 0. That is what is given here. When h of t is a given function, and if it is equal to 0 for any value of t less than 0, then the system is causal. So such a system is nothing but unit step function. Okay, so unit step function, you might be knowing what is what is a unit step function. Therefore, it can be a causal system because unit step function starts at a particular time and remains constant for the next duration until it is stopped. Okay, so such type of systems, if we apply, then if it is used, then it is a causal system. So what should we do? We need to first apply the Laplace transformations for this equation with initial rest condition, that is initial conditions to be 0. Therefore, Laplace transformation of d square y of t by dt square gives us only s square y of s, because y of 0 and y dash of 0 will go to 0. And Laplace transformation of 7 into dy by dt is 7 into sy of s. Laplace transform of 10y of t is equal to 10y of s, and so on. We get 4x of s plus 5s into x of s, because Laplace transformation of dx by dt is s into x of s. So the transfer function is here we are given y of t is the output and x of t is the input. Therefore, we get transfer function as y of s by x of s, which is equal to 4 plus 5s by s square plus 7s plus 10. Okay, this is the transfer function which we have got. Now we need to understand what is an impulse response, right? Before going to the impulse response, we will just partition our denominator into factors s plus 2 into s plus 5, which we get s square plus 7s plus 10. Just rearranging this transfer function, the denominator. So y of s can be equal to, now if we cross multiply x of s to the other side, y of s can be 5s plus 4 by s plus 2 s plus 5 into x of s. Now we have x of s as the impulse input, isn't it? Because they have asked us impulse response, we should take the input as impulse input, where impulse input is equal to 1. X of s is equal to 1. So here x of s is equal to 1. So y of s becomes only 5s plus 4 by s plus 2 into s plus 4. So applying partial fractions to y of s, which is nothing but our impulse response in the s domain, we can partition this into a by s plus 2 plus b by s plus 5, which is equal to 5s plus 4 by s plus 2 into s plus 5. Okay, so how to calculate a? You all might be knowing what is partial fractions, how to calculate a and b. Just for your convenience, I have also given only for a here. So we can consider a is s plus 2, the denominator of a, we'll be taking it here into 5s plus 4, the entire transfer function 5s plus 4 by s plus 2 into s plus 5, and s plus 2 and s plus 2 gets cancelled here, and we replace s with minus 2 in this entire remaining portion of a. So 5 into minus 2 is minus 10 plus 4 is minus 6, right? And minus 2 plus 5 is 3. So we get minus 6 by 3 is minus 2. And similarly, we can get b is equal to 7. So eventually, what we are going to get, y of s is equal to a is minus 2 and b is 7. So minus 2 by s plus 2 is written here, plus 7 by s plus 5 is written here. Now we need to apply the inverse Laplace transformations to this already obtained y of s after partial fractions, and hence we will be getting y of t is equal to minus 2 e power minus 2t plus 7 e power minus 5t. The inverse Laplace transformations are quite easier for a simple pole, 1 by s plus 2 or 1 by s plus 5. It is e power minus 2t and e power minus 5t respectively. So minus 2 and 7 are the constants which are left as it is. So this is our answer, and we need to find out where this answer is in the options given above. So here we have minus 2 and 7. This is where we got minus 2 and 7, b, and e power minus 2t into e power minus 5t. Actually, this is e power minus 5t. So the answer should be B, option B, right? So this is a typographical error. E power minus 5t is for every second factor in every option, e power minus 5t, e power minus 5t, e power minus 5t, and e power minus 5t. In fact, I would like to write down this. This is e power minus 5t in each case. Okay, this is a typographical error. Just bear with me for this error. So the answer is option B, and this problem is given in GATE 2017.